Hey guys, this is Fozon, and in today's lesson, we're going to be discussing two-dimensional arrays. Our lesson objectives, we're going to learn how to declare and mutate 2D arrays, and then traverse through them. So what are 2D arrays? Well, they're pretty much just arrays within arrays, or an array of arrays. The best way to visualize a two-dimensional array is to think of a table with more than one row. When we were thinking about our one-dimensional array, we sort of visualized it as a one-row table with many columns, but ultimately everything was linear. However, with 2D arrays, since it's an array within an array, we have to assume, or our best visualization for a two-dimensional array would be a table with more than one row. So each row would represent one array. So we would have one array that would have 6942. We would have another array that would represent 0618. We would have the third array be 3257. And then we would have the final array being 1343, depending on if we initialize it like that. The length of this array would be 4 because it has 4 arrays within the array. This is how we declare a two-dimensional array. Rather than having one pair of brackets after the integer or after our data type declaration, we're going to have two to emphasize that we were putting an array within an array. So we have two brackets here and two brackets here. Then we're going to have our standard identifier that's going to reflect the context. I just have my array in this case, and we're going to assign it into a new int. And just like how we had two brackets here, we're going to have two brackets after the integer as well. And this will represent the number of rows that we want, and 4 is going to represent the number of, columns. This is subject to change depending on what or the size of the two-dimensional array that you want, and this will follow the standard automatic initialization rules. For example, integers are going to be automatically set to 0, doubles are going to be 0.0s, booleans are going to be false, and objects are going to be set to null. It's also important to mention that this value actually also represents the length of the array. The length of the array is, 5. The length of the two-dimensional array, let me be more specific, the length of the two-dimensional array is 5 because there are ultimately 5 arrays within our array. However, the length of the array within the array is going to be 4. So if we look deeper into our two-dimensional arrays, the arrays that are within our array, they are going to have a length of 4 respectively. Just like how we can do with one-dimensional arrays, we can also use initializer lists for two-dimensional arrays. And this is a little bit tricky, but I think you guys can get it. So rather than having one bracket and then one pair of brackets and then putting the values within it, you have to remember that this is ultimately an array within an array. So I have it set like this so that it makes more sense visually. So if I do double with my declaration with the two brackets to emphasize that we want a two-dimensional array, our identifier, we're going to have a set of curly brackets, and this will consist of all the values that we want, or rather all the arrays that we want, the first pair of curly brackets. Then the other pair of curly brackets are going to represent the arrays within our array. So 3.14, 4.15, and 4.2 are all going to represent one array. The second array is going to be 2.34, 8.90, and 3.40. That's going to represent the second array. And then 6.69, 4.22, 7.33 is going to represent the third array. So you could say that this two-dimensional array has a size of 3, but each array has a size of 3 as well. So the length of the two-dimensional array is going to be 3, and the length of the one-dimensional array within the two-dimensional array is going to be 3 as well, because we have 3 elements. So that's why it's a 3 by 3 two-dimensional array. So to actually access and mutate elements of a two-dimensional array, we're actually going to have to access two positions within the two-dimensional array. So when we're accessing a value, we access it by the name of the array, And rather than having a simple integer position, we're going to need two integer positions. The first value is going to represent your row. The second value is going to represent your column. And if you put this within the print statement, it's going to print out whatever the heck you're printing, whatever the heck you're accessing when you're accessing this location of the array. And this will also follow the standard rules of positions. So it's going to start at position 0, whether you're accessing the row, whether or not you're accessing the column, it's going to start at position 0. So keep that in mind. And if you want to mutate it, it's just the same, except now you have to use the assignment operator and then put your value after you access the element that you're mutating. So you're accessing the element, the name of the array, the row that you want it, and the column that you're at, and then you're going to put your value. So let's just do a quick example. We have our double array. We have our first array being this, our second array being this, and our third array being this. So this is going to be a two-dimensional array with a two-dimensional array size or two-dimensional array length of 3, as well as an one-dimensional array size length as 1. I keep saying size. The proper term is length. Size is something that we use with array lists. Again, that'll be another video. So if I want to change this, one of my values to 8.91, I'm going to access it through my position values and then put that around inside our brackets. So let's say if I want to change 3.14, well, we're going to access row 1. So this is row 0, this is row 1, and this is row 2. Again, follow the standard rules of positions. So again, it's going to start at 0 rather than 1. This 2.34, 8.90, and 3.4 row is going to be row 1. And then we want to access column 2. So what is column 2? Well, 2.34 is column 0, 8.90 is column 1, and 3.40 is column 2. So it's going to replace 3.40 because that is in row 1, column 2. And it's going to replace 3.40 with 8.91, and we should get an array like this, or two-dimensional array like this. And as you can see, it makes the respective change after we have the assignment operator done. Let's go into the compiler and actually declare a two-dimensional array and then traverse it through it. So before I actually tell you how this print array method works, we're going to actually type out two-dimensional arrays within our Java compiler, and then I'll explain the syntax of the print array in two different manners, one with a regular for loop and then one with the for each loop that I have here. But for now, we're going to use this print array to visualize how a two-dimensional array would look. So let's declare an integer array, and we declare it like this. We have two brackets. Let's name it my integers. And let's set that equal to a new int, and then our two brackets there. Oh, that's not how it should be instantiated, and that's cool. We wanted to have a 4x4. We wanted it to have a 3x3 size or 3x3 length, so we're going to put that there within our brackets. Hopefully, when we access the print array method, it should print out a 3x3 array, a 3x3 two-dimensional array with just 0 values. So let me access my integers, and it hopefully should print out. And as you can see, it makes those respective changes. Now let's change the elements within our my integers two-dimensional array. So let's say if I want to make the middle value 9. So let's do that. So to access the element within the array, we first call on the name of the two-dimensional array. Then we look at what we want to change. So the value that we want to change is right in the middle. So what row is it in? This is the 0 row, and this is the first row. First, technically second row, but it's going to have a position 1 rather than a position 2. So we're going to use position 1 as the row. Now, we now have to access the column. This, well, that selects everything, but this is the first column. Then this is the second column, and this is the third column. So the second column is what we want to change, However, we realize that it starts at position 0, so position 0 is going to be the first column, position 1 is going to be the second column. So the coordinates that we have are 1, 1. Let's set that equal to 9. And as you can see, it makes the respective change to position 1, position 1. Otherwise, coordinates 2, 2 on our row 2, column 2 on our two-dimensional array. But if we're doing this in terms of computer science, it's technically the position 1 row and position 1 column. Let's do this with doubles. So let me move that. So we have a double. And let's set that equal to my doubles is equal to new. Actually, rather than using the new operator or the keyword, let's make an initialization list. Hopefully that's spelled correctly. So let's do 1.0, 2.0, 3.0. That should be our first array. Let me separate it with commas to make it a little bit more easier to make out. Actually, not commas, more white space. Technically, white space is the keyword, but it's not really white space here. Let's do 4.0, 5.0, and 6.0. And let's do the final array within our array. That's going to be 7.0, 8.0, and 9.0. Since this is the final array, we're going to now finish the array, the original array that encompasses everything. Now we have to make sure that the compiler knows that we're dealing with a double array. So a double two-dimensional array, so we say new double right before the initializer list with the 2 brackets. Now since we're using an initializer list, we don't need to set in the size through the brackets. It does it automatically since we have the values already there. Let's now access the print array method with the doubles values, and let's change it from integer to double in the respective locations. Okay. Hopefully that should work. Actually, I made a mistake there. This is not supposed to be val. This is supposed to be double. Okay, so now let's print it out. And as you can see, it now prints out 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 values, 9 double values, but it does it and it's stored in a two-dimensional array. Let's change a value within our array to show you that we could change values even after we initialize values within it. So these values are not set. These are not final values. These are values that can be subject to change. So let's do my doubles. Let's access again. Actually, let's access the bottom row over here. Actually, no, not the bottom row. Let's access 8.0 since it's going to have a different row number and a different column number. So this is going to be position 0. This is going to be position 1. And then this is going to be position 2. So our row that we want to deal with is position 2. Now we have to access the column. The column that has 1.0 is column 0. The column that has 2.0 is column 1. And the column that's 3.0 is column 2. And since 8.0 is in the column with 2.0, it's going to be the column with a position of 1. Let's change it from 8.0 to, well, let's change it from 8.0 to maybe 10.0. Just lost my train of thought thinking of a number. It's going to be a little bit weird because it's going to be 1, 2, 3, 4, 5, 6, 7, 10, 9. But this is just to show you that we can change numbers. And it changes it from 8.0 to 9.0. Finally, in this video, I want to discuss how to traverse through a two-dimensional array because it's a little bit more different than a regular one-dimensional array in that you have to account for the array within the outer array. When you think about it, the key to understanding this traversal is understanding that this is simply just an array within an array. So let's do it the hard way first. So we're going to use the standard for loop. For integer I is equal to 0, I is less than the array that we have as our arguments. So we're getting an argument of a two-dimensional array argument with double values. So we're going to use the length. Now this is going to return the number of rows. That's very important to mention. This returns the number of rows, re.length. So how many rows do we have in this? Well, we have 1 row, 2 rows, and we have 3 rows. So this is going to traverse through every single row, but now we need to traverse through every single column or every single element within each row. So how do we do that? Well, we create another for loop. We can label this for integer j. For integer j is equal to 0, j is less than. But now how do we access the number of elements within this array? Well, ultimately, when we access it, we can access this array or this array simply by calling the two-dimensional array and then calling on, well, the array number. So unlike one-dimensional arrays, it already has a one position, and that one position tells us that we have one element. However, when we use this with a two-dimensional array, now we're getting somewhere different, because now this doesn't represent a element within an array. This represents an array altogether. So I is not an array element. Oh, that's a mistake there. I within the brackets doesn't represent an element, just like what we would see in a one-dimensional array. In a one-dimensional array, this would probably represent one element. However, in this case, it doesn't. It actually represents one array. It's important to mention that, because if this represents one array, what does it have? It has a feature that tells us the length. So we could do dot length, and then let's increment j. And as you can see, it works. Just to sum it up, if I didn't make it clear, re.length is the two-dimensional array, or the number of arrays within our two-dimensional array. Rei represents something different. It represents one array, or a one-dimensional array within our two-dimensional array. So it represents this in our first iteration. In our second iteration, it represents this. In our third iteration, it's going to represent this. And since it's representing an array has a dot length feature that returns the number of elements within the array. It's easy to mention. It's easier just to change the variable names so that it makes sense. So integer I can be written as row. Let me make that respective change. And integer j can be written as column. Now let's print out the value that we have at each element. System.out.println. Actually, not println. Let's do the regular print statement so that it stays on the same line. And then let's access the elements. So we have re as our two-dimensional array. We have our I value to access the row. And we have our column value to access the column that we're at. Let's add a space so that it's all spaced out. So this outer for loop is going to represent all the rows. It's going to iterate through all the rows. And the inner for loop is going to iterate through the columns. Let's print it out and see if it works. And as you can see, it prints out our our two-dimensional array. However, this doesn't really look good. So how do we make sure that after every single row, it prints out, after every single iteration of a row, it starts a new line? We could simply just add a print statement after we iterate through the columns. And after we iterate through the columns, it knows that the row is done, and we're going to start on a new line. and there you go. It now represents a two-dimensional array in a way that looks more practical and captures the visualization of a two-dimensional array. Now let's do this with a for loop. Sorry, we already did it with the for loop. Now let's do it with the for each loop, which might make a little bit more sense and might put this in much more simpler terms. But if you ever have a problem where you might need the row and column value, say if you want to return it back to the user, if you're using an implementation or method implementation that has a return type, then you would most likely use row and column. But if you're dealing with just the values within the element and nothing much, you don't need to know its position or whatnot, then you can use the for each loop. So the for each loop is different because it's just not different. It's gonna be a little bit more simpler, but it's gonna follow the same format in that there's gonna be a for loop within a for loop. So the outer for loop is gonna traverse through all the rows. It's gonna traverse through all the arrays within the arrays. So the data type that we use outside is a array data type, a one-dimensional array data type. So let's name this temporary array val array, and it's going to traverse through the two-dimensional array. So it's important to note, and I keep coming back to this because understanding this makes the traversal process much more easier. Just remember that two-dimensional arrays are just arrays within arrays, or an array of arrays. So this is traversing through all the arrays. So this outer for loop is going to execute 3 times. It's going to have 3 iterations because there are 1, 2, and 3 arrays. So each array is going to get its own iteration. Now we want to print out every value within each array. So we access this array. We made a new array. So let's access this array and then put that into a for each loop as well. So that's going to have just a simple double data type rather than a double array data type that we used previously. And it's going to traverse through the array we just made using this for each loop. Let's name the identifier val, and it's going to traverse through val array, the value, sorry about the stuttering, the two-dimensional array that we just made. The one-dimensional array that we just made that is traversing through the two-dimensional array that it takes in the arguments. Let's print it out. So we print out the value that we get throughout every iteration. So you could say that this for loop executes 9 times, this for loop executes 3 times, meaning that this iterates 3 times total, this iterates 9 times total. However, it's important to note that this for loop does it 3 times within this for loop. So every row has 3 values. So if it has 3 values and we have 3 rows, then 3 times 3 is 9. That's why this for loop gets executed 9 times. But 3 is for each iteration. There are 3 iterations of the outer for loop. Let's add a space. And just like our previous for loop, we're going to make sure that after every row is done printing out its elements within the columns, then we start a new line through the println statement. And as you can see, we get the same result as we did with the regular for loop, but rather than using the regular for loop that makes us keep track of all the positions that we might need, we have a for each loop that covers the positions in the back end. But I keep coming back to this, and I will mention it again. Just recall that a double array, a two-dimensional array is just an array of arrays. So our for loops or our array traversals are going to reflect that. So you're traversing through the two-dimensional array, the outer array, and then you're going to traverse through the inner array each time. So the outer for loop is going to traverse through each iteration is going to represent one array within the two-dimensional array. And then the for loop within the for loop is going to iterate through the elements within each array, or the columns, one can say. I hope you enjoyed my video on two-dimensional arrays.